One of the physical characteristics of soil that really plays an important role in both the workability of the soil and the ability of the soil to either handle pollution or not handle pollution, or to be used as a growing medium or not be used as a growing medium, is soil texture. And soil texture is an interesting study because texture determines a lot of the other physical characteristics of soil. So before we talk about soil texture directly, we have to talk about particle sizes in soil. In soil texture, we divide particle sizes into three categories: sand, silt, and clay. Sand particles are typically the biggest particles associated with the mineral matter in soil. Silt particles are smaller than sand, but they're bigger than clay. Clay particles are the very smallest particles found in the mineral matter of soil. As a comparison, sand particle might be 2 millimeters down to about 0.5 millimeters. A silt particle might be 0.05 millimeters down to 0.002 millimeters. A clay particle, on the other hand, is less than 0.002 millimeters, or 2/1000ths of a millimeter. Very tiny particles. Interesting thing about clay is that some particles are so small that they will stay suspended in water if you shook up a sample, and they'll never settle out because of the lack of attraction of gravity to that small particle. This is why some ponds and lakes that you may encounter seem murky all the time. In clay areas, typically, water has a tendency to become murky and stay murky. In sandy areas, water has a tendency to maybe kick up the sand at times, and then the sand quickly settles out, clearing the water. Silt, on the other hand, if the water is slightly in motion, silt can stay suspended in water for a long time. In determining soil texture, we have to look at a soil chart. And the soil chart is a triangular invention of humans that actually has their percentages of sand, silt, and clay located on the sides. So if you can envision a triangle, on the bottom side, we have 0 to 100% sand in a sample. On the right side, sloping from top to bottom, we have a 0 to 100% silt located along a number line. And on the left side, from the bottom left to the top, 0 to 100% clay. Determining soil texture is simply determining the proportion of sand, silt, and clay to each other. Soil texture has a great deal to do with many other soil characteristics, as I mentioned. In working through a sample, say we found a sample of soil and determined that it had, let's say, 55% sand. And then we also found out that the same sample had approximately 25% clay. Right away, we know that that's nearly all of the sample, but that would equal about 25 plus 55 would equal about 80%. So that tells us the rest of the sample is going to be 20% or so silt. Where the three lines intersect on our soil chart tells us what type of soil that is. In this case, a sample that contains those proportions of sand, silt, and clay would be called sandy clay loam. And looking at another example on our soil chart, what we would find is if someone gave you equal proportions of sand, silt, and clay. To determine the proportions, we run the soil through a physical test, not chemical test, by shaking the sample up and dislodging all the particles and allowing the particles to settle back out during varied time increments. If we were given a sample that contained 34% sand, 33% silt, 33% clay, roughly 1/3 of each of those, then we would find those on the soil chart in the very center of the soil chart, and we would call that sample clay loam. I have a prepared sample, just as a demonstration, of a soil sample that has undergone the process of separation into sand, silt, and clay. The way that we prepare the sample, we simply take the entire soil sample, add an anti-flocculating agent to it and water, and shake it. Once we shake it, the soil particles separate, and we pour the entire sample into the first tube and allow it to settle for 1 minute. At that time, all the sand very quickly settles out of solution. After exactly 1 minute, we take that sample and pour the liquid into the next tube, at which point we allow it to settle for another number of about 5 minutes. During that 5-minute period, all the silt in the sample will settle out. At the end of the 5-minute period, we'll take the remaining liquid and pour it into the third test tube and allow what remains, which would be clay particles, to settle out over. It actually takes an overnight period for that to happen. We would then check the relative proportions against our first sample. So if this sand sample turned out to be somewhere in the neighborhood of, let's say, 75% of the entire sample, and this turned out to be, let's say, about 20% of the original sample, that'd be our silt amount. And on the far side, the clay amount turned out to be the remaining, which would be 5% of the original sample. We can then go back to our soil chart as we did before and use that to find where those three lines intersect and determine the type of soil texture that we're working with. Farmers do this a lot because it determines the workability of the soil. And sometimes, if you have poor soil for growing things, you can add what's called soil amendments to the soil to be able to help change that texture. However, in environmental science, different textures of soil allow for the movement of different things like nutrition, and especially we're interested in pollution in the soil to move through the soil vertically in the form of either leaching through permeability down and possibly into groundwater. So that's how you determine soil texture, and it's quite an easy test, and if you get a chance to try it in the classroom, that would be great.